again, this is Robert Veach here. This is going to be a video review of several products. This is in front of me the Splitvolt brand, their 24 amp, which uses the Nema 1430 outlet. It's an EV charger. It has a 16.4 foot cord, which I've measured, and it's one of the fastest NEC-safe 30 amp charging circuit out there. This will charge at 5,760 watts. It's compatible with all EVs using J1772 universal plug, including Hyundai, Ford, Chevy, Audi, Nissan, Volkswagen, and Tesla. With Tesla, you do need an adapter. It has a 1-year warranty from the company, and this is a portable way to fast charge your cars at home. Now, there's 3 different levels of charging that you can do in an EV right now. You have the slowest, the trickle charging, which is the 120 volts that usually comes with the car, and that gives you about 2 hours of driving range, 2 to 3 hours per hour. Then you have the medium, which is what this is, and then you can also get ones for 50 amp circuits, which I'm calling the high. This one right here will get you about 20, 25, 26 miles per hour of charging, which is adequate for a lot of people. In fact, it might even be adequate just to have the standard 120 volt one that comes with your car. Because if your car is sitting there, you can just charge it. The advantage of something like this is that you can charge your car quickly, relatively quickly, 6, 7, 8 hours overnight when the rates are lower. So if you have 120 volt in there and it's taken 3 days to charge, it's going to be charging during the day, taxing your system and getting your lower rates on your electricity. So there's no installation required. This just plugs right in to a dedicated Nema plug right there, and we're going to show the full installation of that plug in my garage, and I'm going to have a separate video of this being used for my electric car. Right now I'm going to show the whole installation of this of the requirement of the plug, and it's going to be all to code, and then we're going to be able to test this on an electric vehicle. So this is all 10 gauge wired. You can really tell it's very, very hefty. So there's a nice silicone plug on here, and it has one of these pull switches that opens and closes that tab right there. Then it has the universal connections on there where it has the sense resistors and everything, and the Tesla adapter would plug in onto this. But that's basically the front of the unit, how that works. And then whenever you're not using it, you want to keep that closed like that. So I want to talk about batteries and charging a little bit real quickly. I've been flying radio control airplanes ever since batteries existed that are chargeable. So I have like 25 different airplanes, and they all use lithium polymer batteries similar to this. This is called the 4-cell because there's 4 individual batteries in there. There's 4 of these modules in there. Now these electric cars use a very similar battery. They're just much, much larger, and they're all stacked inside there. Now one thing I've learned after doing this for over 20 years is that you could charge batteries really quickly, or you could charge them really slowly. What I've learned is that I keep that in between. I charge them at the medium rate. I don't quickly charge them. And by doing that, batteries last longer. When they start to get a little bit older, they get a little bit thicker. But if you maintain the battery at that medium rate, you can see this is a battery that's 7 years old and it still is fine. So my point is that this unit, the Splitvolt unit, is what I would call the medium charger because of the kilowatt rating that I mentioned on here, the 5760 watts. Yeah, you can go to the 50 amp circuit, but I wouldn't recommend it. I recommend this if you're not in a real hurry to charge your vehicle. This is fast enough. So that's my experience, and I'm going to go and show you the other components that are going to be shown in this video review. First product is the Romex style cable, and this has 4 conductors in there, as you can see, and that's where we're going to bring the power to the outlet in the garage. This is the powerful drill I'm going to be using. It's a brushless Rockwell, and that's going to be drilling the hole into the wooden beam to go to my garage. This is the very long auger bit, 3/4 of an inch, to allow me to drill the hole I need to drill. These are the staples that are going to be hammered into any wooden beams. They're going to hold that Romex cable. These are the push connectors that are going to hold the Romex cable into my electrical box. Here's the box we're going to be using. That's going to hold that Nema outlet in there. It's a 2-gang box. Here's the Nema 1430R, and this we're going to be using as the outlet for the 240 30 amps. And you can see the back of it has really high gauge holders because this is meant for 10 gauge down to 4 gauge. Here's a beige cover that's going to cover that Nema 1430R. And we're going to show the installation of the Electron J1772 connector. Has the included hardware and the holder for the connector and your connector cord holder also. Okay, so the first thing I'm going to do is I'm going to drill. I already started a pilot hole with a smaller drill. I'm using the long bit on the slow speed with the Rockwell cordless. And I'm going to be trying to increase the size of this. So as you can see, that worked really well because this bit is pulling out the wood and the drywall as it goes. Now we should be able to feed the Romex through there now. Now we're going to feed the Romex, or the whatever it's called, the sheath cable, and we're going to feed that through that hole we just drilled. And we're going to try and keep it as flat as we can. Now we're going to go to the garage and make sure that this is pulled through. So here's the hole as it came through. You can see it's right there, worked perfectly. This is one of my air hoses that I have coming in from the basement. So the code changed for the National Electrical Code changed in 2017. So if you have this on the outside of your garage, you have to protect it with like a real thick piece of conduit. It's got to be 3 times the width of this, or that PVC Schedule 80 you'd have to put on the outside. So what I'm going to do, I'm going to open this wall up and I'm going to see what's behind here. This is called the Sheath Wall, so it's fireproof because the house is that way. And I'm going to open this up and I'm going to feed this through the studs, which is code, and then I'm going to have the electrical box right here, probably at 45 inches high. Code is up to 48 inches, and I'll have that 240 volt outlet right here. So the first thing I'm going to do, I'm going to use these MC cable clamps, and I'm just going to start going. That's the first one. I'm going to move along and I'm going to keep doing this until I get to the breaker panel. So now is a good time to put some caulk in the hole that you just created for support, and so that you don't get any mice or bugs into that opening. So here I have the Romex cable. It's in the center of one of the studs that there. Turns out this is not a supporting wall. It's just a kind of a cosmetic wall. The supporting wall is behind it. But still I'm following code. And here is the Romex cable now. And you can see I added some wooden studs right there. And I actually added additional wood so that it intersected the back studs for extra strength. You want that to be strong because the box I'm using is rated for like a couple 100 pounds, and these charger 240 volt are heavy. So make sure you make that pretty secure and have it on a stud. That's code also. So this electrical box has tabs that come closed up, and I just use pliers and pop this through there so I can take the Romex and feed it through the box. Now before we put this in the box and then mount the box, I'm just going to show you there's a lot of ways to remove the outer coating or material on Romex-like cable. Probably the safest way is just to take a pair of pliers and start peeling it back. And the reason that's the safest because you're not using a blade and you're not running the risk of cutting these cables, because you don't want to use a blade and you don't want to cut the insulation. Even a micro cut you might not see, but this way you're doing it totally safe because the wire is being protected by the material on there. That's my recommendation. So now I have the outer cover removed so it can go into the box, and you could now strip the wires if you want, and there's several ways to do that. You might have this in your toolbox. This has the gauge and it has a way to strip the wire, or you have one of these automatic type. Either one will work. I'm not going to do that just yet because I'm going to first feed it through the box and mount the box. So here I have the wires of the Romex fed through, and this particular box has 2 mounting screws. Now as I showed, I have studs there, so I should be able to line this up. So I'm going to do the top one first. I'm going to line the bottom edge with the drywall. And let's tighten the top one now. And you don't want to over tighten it. That's it, and it's in there really tight now. So here I have the drywall put back together in sections, and I highly recommend that you do the mud work before you bring the connector in so that you don't get drywall compound or drywall dust in the connections. So let this dry, sand it or wet sand it, and then paint it, and then go ahead and install your Nema 1430. So here I have the wall painted and ready for the install of the Nema 1430. And you can see that I stripped the wires, left about 3/4 of an inch on there. Then here's the ground wire. Here's going to be the hot A, the hot B, and this is the neutral wire. So on the Nema 1430, on the back it has different colors of the screws, you can see, to make it easier. So you see that green right there is going to be the ground, and you see those gold ones there, those are going to be the hot A and the hot B, and you see that silver one right there, that's going to be the neutral. So we're going to insert them in here. We're going to turn these screws and tighten it down. So here you can see I've got them all installed and tightened. You can see that bluish green has the ground, and the red goes to that gold connector, and the black goes to the other gold connector, and the white goes to the silver looking connector right there. And I'm going to test it with an ohm meter just to make sure. Make sure that you tighten these down, because 10 gauge is really thick wire, and you got to really tighten these down to grip them. Okay, so I have it connected, and I checked it with an ohm meter, and it's correct. The ground is going to go face up because the charger that we're using, when you plug it in that way, it drops down. It has the display on the bottom. That's what they recommended from the manufacturer. Now I have to admit, this was really hard to get these wires in there. I'm actually sweating. You have to be careful you don't cut yourself, because these wires have so much resistance mechanically, and I was essentially keeping them nice and long so I could pull this out and do any service or change it easily. But I paid the price for that. You can clearly see that you need a 2-gang box, which is what this is. You just need that volume and that space. Now we're going to put the screws on and tighten this down. So there I have them tightened down, and don't over tighten it. You don't want to strip those threaded pieces on that polyethylene. So there, now it's installed. I've got the ivory cover on it right now. So this is not hooked up to the fuse box yet. That's what I'm going to do next. And it's a good idea to put a sign, a laminated sign, so that people know, who's ever using this, that this is 240 volts, 30 amp service, an outlet type Nema 1430, and then a ground fault at fuse panel. So here I have it ran, and I was putting one of those holders about every 2 beams going across. Sometimes I put it every beam. And it comes down to my electrical box, and it's going to go in right there, and I'm going to mark the point where it goes in to that opening cap, and then I'm going to remove the outer insulation on here. Then we're going to show the wiring to connect that 2-gang 30 amp ground fault fuse next. So here is the circuit breaker we're going to be using. This is the square D 2-pole home line circuit breaker and ground fault circuit interrupter. Now you can see it has this white wire coming out of it. This is pre-wired. It's nice and long when you uncoil it, and that's going to be wired directly to the bus bar on the box. Let's go to the bus bar up there. You can see the bus bar right there. There's one on the left and there's one on the right. I'm going to be using the one on the left. So that gets connected right there. And then we have the incoming 2 hots, and we have the incoming white and the ground. That copper ground is going to go to that bus bar also. And then the fuse itself has 3 terminals on it, as you can see right there. On the sides are the connections, and it's just a regular screwdriver you can use in there. I'm using one that is insulated, make it safer. But you're basically going to put your white wire that's coming from the Nema outlet into that center one, and the red and the black there, and that's what's going to allow you to transfer over the 220 volt hots. So the idea is that when this ground senses a current, it's going to turn off these connections, and that's the whole point of it, for safety. There I have them tightened down. You see I got the neutral that goes to the Nema in the center, and I've got the black and the red hots that go to the Romex out to the Nema outlet. Now the way this plugs in, it's going to have to go across those terminals right there where you have the 120 A and B. Now it's kind of hard to move this because it has those wires on there, but this is going to go into the left side like that, and then you push, because I still have to connect the fault sense ground and the copper ground from the Nema So here it's all wired down, and I have the fuse turned on. I've got the copper going to the neutral and the current sense going to the neutral, and you can hit the test button, and it's important that that reacts like that, letting you know that it is functional, because the test button is putting about 10 milliamps of current through that neutral wire. Take two. Now on your box, the cover, you should be able just to knock out those pieces of metal right there to allow the opening of the 2-gang ground fault that we just installed. And there, now I have the cover back on, and you can see it accommodated the 2-gang GFI perfectly. So here we're going to test the Nema 1430. So I have a voltmeter on auto and AC. So I'm going to go on, or the neutralized, and I get 124.6 volts. And the other hot, I get 123.6. And if I go across like that, I get 248. So it's wired correctly. So here I've plugged in the Splitvolt to the 240, and you can see it came on, and I've got a green indication. Next thing is to test it on the electric vehicle. So it's very simple to mount. You just put the 4 screws in there. This plastic piece goes first, and then the metal goes second. Then you have the standard connector on there, keeps it in place. And then you have the cable holder right there to allow you to hold the cables. Now we're going to charge my EV. Very simple. You just push that button right there and it releases it. So I have my charging door open of my Hyundai Kona, and I'm going to plug it in. Push this button here, push forward, then you see the indicator light comes on and then it goes green. Now it's giving me a little status indicator right there. And on the split volt unit, you could see that the power light was on before, and now that it's blinking, that it is successfully charged. There's no fault indicators on there. So you can see a wide shot right there, and you can see the split volt that's successfully charging my new Hyundai Kona EV.